open up your book to section 7-3, we're on page 351 in your book. And the title of this section is Identities and Algebraic Transformation of Expressions. The objective is, given a trig expression, transform it into an equivalent expression whose form is perhaps simpler or more useful. And as you saw in the first part of this section, we were dealing with trig transformations, where they told you start with this expression and rewrite it so it looks like this other expression. And we went through the guidelines, and those kind of took us through some algebraic and trig guidelines that we could use to help us go through that process. And the good news for us is that we're going to go through the exact same thing here in the second half, except we're going to deal with the identities part of this, which is basically the same idea as a trig transformation with one slight difference. All right, so let's talk about that. What exactly is a trig identity? A trig identity, and this applies to any identity mathematically, but a trig identity in particular, is a trig equation that is true for all values in the domain. So an identity in general is just an equation that's true for all values in the domain, but a trig identity is a trig equation that's true for all values in the domain. So if you remember, they've given us a set of guidelines here at the end of this section that we went through. And with trig transformations and with trig identities, you go through basically the same guidelines to help you solve those. But there is one slight difference here when you're dealing with a trig identity. And it's the very first one there. It says you're going to have to pick the side of the equation to start with and write it down. So unlike the trig transformation, they said start with this and end with that. They gave you the start and the end. Now they're just going to give you those two parts, and you have to figure out which one of those should I start with and which one should I end up with. Usually, as it says here, usually it's easier to start with the complicated side and then simplify. And you might think that sounds a little bit backwards at first, but it usually is easier to start with something more complex and then go through a process to simplify that down versus starting with something in a really simplified form and then try to make it more complicated to get the other side. So that's why we start with the more complicated, the more complex side. All right, so let's take a look at a few examples here. And we're going to take the guidelines that they gave us in the first half that we went through. We're going to take the knowledge we've gained from that, as well as the properties we learned in section 7.2 to help us find these or prove these trig identities here in this second half. So look at example 3. Example 3 says the following. It says prove algebraically that 1 plus cosine of x times 1 minus the cosine of x equals sine squared of x is an identity. So they want us to prove this, that 1 plus the cosine of x times 1 minus the cosine of x is equal to the sine squared of x. All right, and this is how I want you to do each of your problems. Write down the identity first, and then write down the word proof. And we're going to go through and prove that these two are equal to each other. Now, the first thing you have to do, as we just noted on the previous slide, is you have to decide whether you're going to start with the left side or you're going to start with the right side and then work your way towards the other side. We're not going to start out by writing down both of these once I write down proof. So it looks like the left side, I think we could all agree, is the more complicated side, and that's the technique or the guideline they suggested, is start with what looks like the more complicated side. So I've got 1 plus the cosine of x times 1 minus the cosine of x. But keep in mind what you're trying to end up with. I'm trying to end up with sine squared. When I see sine squared in there, the fact that it's squared, that should be a hint for me, or I should be thinking about there's perhaps a Pythagorean property I'm going to use in here. Anytime I see those things squared, that's probably a good hint that there's a Pythagorean property. I think the first thing to do is some algebra here. I've got 1 plus cosine times 1 minus cosine. In fact, those are conjugates. Those are really nice to multiply together. So let's go ahead and multiply those out. It'll be 1 times 1. The middle term will drop out. The 1 minus cosine times and then added to the cosine of x times 1. Those cancel out. It'll be times or excuse me, it'll be minus the cosine squared of x. 1 minus the cosine squared of x is what we end up with when we multiply that out. And 1 minus cosine squared, again, you need to know your Pythagorean properties here. But my Pythagorean property says that cosine squared of x plus sine squared of x is equal to 1. So that means that 1 minus the cosine squared of x is sine squared of x. I know we don't write the Pythagorean property in that form, but you should be able to manipulate that property and recognize this one right here. 1 minus the cosine squared is in fact sine squared. And there we go, we're done. Start out with what you have on the left side in this case, and we kept going until we finally ended up with what's on the right side. Again, notice I'm not writing down both sides of the equation to start off with. I'm only starting with one side and work my way until I logically come up with the other side. All right, look at example 4. Example 4 says, prove algebraically that cotangent of A plus the tangent of A is equal to the cosecant of A times the secant of A. So let's write that down. Cotangent of A plus the tangent of A is equal to the cosecant of A times the secant of A. I want us to prove that that's an identity. And again, I want you to write down, first of all, the property that you're trying to show, or the identity we're trying to prove. Write down the word proof. And then let's go through and prove this. So again, the first thing you have to do is pick one of the sides that you're going to start off with. And we said pick the one that's more complicated. I would say that since the left side of this is a sum of two terms here, cotangent plus tangent, I would consider that to be the more complex side. So I would start with that. Now, if you look at the more complex side and you go, well, I don't really know what I'd do in my first step, but over on the other side, I'd know what I'd try to do the first step, then there's nothing wrong with picking the other side. In fact, that's probably a good option if you have an idea of what to start with it. And you don't have an idea of what to start with here. But I think I got an idea of what to start with here because I've got the sum of two terms. And we've talked about how to go from two terms down to one like I want to have over there on the right side. And so let's do that. I think the first thing to do is to rewrite this in terms of the quotient properties. So I'm going to do that. Cotangent, I can rewrite that as cosine over sine. So the cosine of A over the sine of A. My goal here, by the way, is to get two fractions that I can then add together. Tangent is the sine of A over the cosine of A. Now in this form, I can't add those together because I don't have a common denominator. So let's multiply by the clever form of 1 to get a common denominator. Multiply this first fraction by cosine of A over cosine of A. That's the second denominator over there. And multiply the other fraction by the sine of A over the sine of A. We're multiplying by a clever form of 1, and we're multiplying by the other denominator in order to get a common denominator is what we're trying to come up with. In the numerator, you have cosine of A times cosine. Oh, that's cosine squared of A. That's actually pretty nice. That's a Pythagorean property, I know. The denominator is the cosine of A times the sine of A. That's the first fraction there. The second one is sine times sine. That's actually pretty nice. That's another Pythagorean property there. Cosine of A, sine of A. All right, so now that we got a common denominator, we can go ahead and add these together. We've got cosine squared of A plus the sine squared of A in the numerator. And that's all divided by the cosine of A times the sine of A. Yeah, that numerator turns out to be pretty nice because that's my Pythagorean property. Cosine squared of A plus sine squared of A is better known as 1. So let's replace the numerator with 1. I have 1 over the cosine of A times the sine of A. And you know, as you're going through this, keep an eye on what you're trying to end up with. If I go back up here, I'm trying to end up with the cosecant of A times the secant of A. All right, so the fact that I see that versus what I have down here, which is in terms of sine and cosine, it might be a hint that, okay, I should rewrite these in the reciprocal form. In fact, let's split this up first of all. Let's rewrite this as 1 over the cosine of A times 1 over the sine of A. I can split up that fraction in this way because I can multiply the numerators and then multiply the denominators and get the same thing. And so replace cosine of A, or 1 over the cosine of A, with secant of A. Replace 1 over the sine of A with the cosecant of A. And oh, right there's what we're looking for. I'm looking for to rewrite this as a product of secant times cosecant. And there we go. We got it. All right, let's take a look at one more example here. It says to prove algebraically that 1 minus the cosine of B over the sine of B. Let me go ahead and write this down as we go through this. 1 minus the cosine of B divided by the sine of B is equal to the sine of B divided by 1 plus the cosine of B. Now these two are, well, look like almost the same fraction, right? I mean, they're not quite the same, but they look like it. I've got 1 in cosine in the numerator on the left, 1 in cosine in the denominator on the right, sine in the denominator on the left, and sine in the numerator on the right. So they look very similar. And so you could probably argue which one you think is the more simplified form or which one's the more complex form. I'm going to go ahead and pick the one that's on the right. I think you could just as easily do the one that's on the left. The only reason I'm picking the one that's on the right is because it has a sum in the denominator. So I guess I would consider that to be a little bit more complicated, but I don't think it really matters here in this case which one of the two you pick. But again, start it out the same way by writing down the property or the identity first. Write down the word proof. And then let's go through and pick one of the two sides. Oops, 1 plus the cosine. Pick one of the two sides that you're going to start off with, and then only write down that side. And now go through the steps here, either using some algebra or trig to come up with what the other side is. All right, so I think the obvious thing to do here, you could, I guess for one of two reasons, argue that this would be the choice to make. But in the denominator, I've got 1 plus the cosine of B. And I think the obvious thing to do is to think about multiplying by the conjugate of that, 1 minus the cosine of B. That was one of the techniques we talked about, was multiplying by conjugates. I guess the other way you could think of this, if you look at what's in the numerator over here, again, I'm trying to end up with 1 minus the cosine of B that I have on the left side. So another reason I might think about multiplying by that is because we said, well, if you see something you want in the numerator or denominator, then just multiply by that and see what happens. So that might be another reason why you say you're going to do this step, but I think this is an obvious step for both of those reasons. So what do we end up with? Well, in the numerator, I don't want to multiply those together because I want to end up with 1 minus cosine of B. So let's rewrite that just in its factored form. Sine of B times 1 minus the cosine of B. You know, sometimes we might actually distribute that or multiply it out, but I don't think it makes sense to do that in this case. The denominator, I think it makes sense to multiply these together because those are conjugates. Multiplying conjugates is really nice. This turns out to give us 1 minus the cosine squared of B. And again, as soon as you see a squaring of one of your trig functions, you should be thinking about those Pythagorean properties. 1 minus cosine squared. We didn't write the property down in this form, but this should be one that I get better and better at recognizing. Cosine squared plus sine squared equals 1 is our property, but 1 minus cosine squared, like I have here, is just sine squared. So let's replace that with what it's equal to. I have the sine of B times 1 minus the cosine of B. And that's all divided by sine squared of B. And oh, I can actually cancel some stuff out now. I've got 1 sine of B in the numerator. I've got 2 of them here in the denominator, so I'll just cancel out that squaring there. And what do we end up with when we do that? I've got 1 minus the cosine of B in the numerator. And just the sine of B is all that's left in the denominator. Oh, and actually that's what we're looking for, right? I go back up here to the top, over there on the left side, 1 minus the cosine of B over the sine of B. That's what we're trying to end up with. There we go. That's our result. So those are the problems that you're working on. Again, use that technique there. Like I showed you, write down the identity first, write down the word proof, and then go through picking one side and only writing down that one side and working your way until you get the other side. And again, if you get stuck on one of these, just leave your work that you have there and just next to it, start it over. Maybe start with the other side if it didn't seem to lead you in the right direction. Start with the other side and work with it. But keep your work there so you can kind of learn from what worked in the previous attempt versus what didn't work. That might help you out. That right there is as far as we're going here in the second part of section 7-3.